Yeah, welcome to the second lecture of the course Artificial Intelligence. So, in this lecture, we'll be discussing about intelligent agents. So basically, intelligent agents or artificial devices which are empowered with some intelligence. So, we'll be understanding the characteristics of an intelligent agent. What should be the characteristic of an intelligent agent? What it should have, or what are its features? And also we'll be discussing more about the environment because the agent is going to interact with the environment. So the agent should be aware of the environment. So what are the different types of environment to which the agent may have to interact? So these are the two major things we'll be discussing. And also we'll be discussing like more about what is a rational agent. A rational agent is something which always tries to do the best thing. But what is best? How will we define that bestness? So the agent should always try to do the best thing. But before that, you have to tell to the agent what is best, or or the agent should be informed like what type of activities will make the agent as a best agent. Okay. So these are some of the things which we will be touching upon in this lecture. So first, what is an agent? An agent is something which interacts the environment, which interacts with the environment, okay, by performing some actions. And what is an rational agent? A rational agent is one that behaves as well as possible. That is, it always do the best thing. This behavior depends on the environment. That is, depending on the environment, the agent's behavior may change. It will not behave in the same way in all environments. Some environments are more difficult than others, right? So this is an important thing to understand. So actually, an agent which is created to work in a very confined environment, probably it may do better. But if an agent is designed to work in a very complex environment, in an external environment, programming such an agent will be very difficult. Okay. So environments are more some environments are more difficult than others. So it's not that all environments are some environments will be very easy. If it is limited to a very limited space, then it may be very easy environment. Then for such environment, we may be able to design the agent also very easily and effectively. So an agent is anything that can be viewed as perceiving its environment through the sensors and acting upon the environment through the actuators. So we can formally define an agent something like this. So the agent should have something should to perceive the environment. It should have the ability to perceive the environment, that is to sense the environment. So it should have some sensors, and based on what it has perceived, and after doing some reasoning mechanism, it should be able to act upon the environment. For acting, it should have some actuators, right? Like how we have hands and legs to act. Similarly, the electronic agent should have something to act. So this is how we can represent an agent. So agent is interacting with the environment. It is perceiving through the sensor. It senses something from the environment, and then it reasons like what it senses, and then what it is supposed to do. It performs some analysis or reasoning, and then it acts on the environment through the actuators. So these are some examples. We can consider human itself as an agent. So if you take a human agent, if you consider the human as an agent, then what are the sensors? Eyes, ears, skins, these organs are these sensors. Actuators, hands, legs, mouth, and other body parts are actuators. Because through this, we are interacting with the world. If you take a robot, if you consider the robot as an agent, the sensors are cameras, sonars, it may have some laser range finders, actuators, or it may have some motors to control the hand and the legs. So all these can be treated as actuators. so so an agent should be able to. So these are some of the properties of an agent. An agent will it should be able to perceive the environment. An agent's perceptual input at any time is called as percept. So always the agent will sense. It will keep sensing the environment. So whatever the input it is taking from the perception, so at a given time that is called as percept. Okay, at this point of time, what it senses, that is called as percept. And what is percept sequence? All the past history of percept put together is called as percept sequence. So what the agent is currently sensing at this time, what it is sensing, that is called as percept. The history of all the past percepts till date or till this time, what it has sensed so far, the entire history is called as percept sequence. Okay. So now the action should depend on what? The action should depend on percept or percept sequence. That depend on the type of the problem the agent is trying to solve. For certain type of problem, it may be just enough to use the current percept and then it can take a decision. But for certain problems, it may have to consider the entire percept sequence. Or for some other problem, it may have to consider some part of the percept sequence. Right? So how much of the percept to be considered, whether the decision can be taken based on the current percept alone, or the entire history of percept is required, or a part of the history of the percept requires, that actually varies from problem to problem, or from environment to environment. And agent function. What is an agent function? An agent function is something which maps the percept sequence to an action. It can be either percept or percept sequence. So that depends on the type of the problem. So an agent function is something which maps the percept sequence to an action. So given this percept sequence, what is the best action the agent can do? So that is what is called as agent function. The ability to program the agent function is called as agent program. The program which is used to perform this agent function, that is called as agent program. The internal implementation of the abstract mathematical agent function. So this should be represented in the computer through some form. For that you should be using some programming language. So representing this agent function through some programming language is called as agent program. Right? So an agent will have all these things, or it should be able to do all these things. It should be able to perceive, it should maintain the percept sequence, it should perform agent function, and it should have an agent program. So here is an example of a vacuum cleaner agent. This agent is confined to a very small world. We call it as mini world. So we are taking a very, very small, very basic example to understand the agent and the environment. So actually this agent is confined to a very limited environment. So this is our environment. Let us say there are two rooms, or not even room, you can say there are two locations. A is one location and B is another location. And this agent is a vacuum cleaner agent. This is the agent. Okay, this is the agent, and this agent is vacuum cleaner agent. What it should do? It should ensure that these two rooms are clean always. That is what its objective is. So what it does, wherever the agent is, so the agent can be currently in room A or it can be in room B. If it is in room A, it will sense. Automatically it will sense. It will sense and it will check the floor whether it is clean or dirty. Suppose if it is clean, then there is no job for the agent in this room. So it will move to room B. So room B is towards the right of room A. So it will move to the right. So this is the action the agent will take when it is in room A and room A is already clean. Suppose the agent is in room A, the room A is not clean, the room A is dirty. In that case, the agent will clean it. In that case, the agent will clean it. So this is what it is supposed to do. Suppose if the agent is in room B and if it senses, and if the and if the room is clean, then it means that the agent does not have any job in room B, so it is supposed to move to room A, so it will go back here. If the agent is in room B and the room is dirty, then it should clean it. So this is the action the agent will be doing. So if both the rooms are clean, then it will be just keep moving here and there. That's all. So assume both A and B are clean. Then agent will move. Agent will check A is clean, so it will move to B. B is clean, then it will move to A. So like that, it will keep doing that. So this is a very small word which we use to represent the agent. So in this problem, we have only two locations. What are they? A and B. The floor can be in two states. Either it can be in the clean state or it can be in the dirty state. So this is one percept, current percept. So percept in the sense, the current time, what is the input we get from the environment, the agent gets from the environment, that is called as percept. So it is perceiving currently, let us assume the agent is in room A. So the agent is in room A and it is perceiving that the room is clean. So what are the actions it can take? So these are the typical actions the agent can take. It can move right, or it can move left, or it can suck the dirt. That is, it will remove the dirt. So these are the actions the agent can do, but it depends on the input that it receives. Okay. So here is an example. The agent is in room A. And room A is clean, which means the agent should go to right. This is the action it is supposed to take. The agent is in room A, the room is dirty, which means the agent should suck, that is, it should remove the dirt. The agent is in room B is clean, which means it should move towards the left, so move left, that's the action. So this is action, okay. The agent is in room B and room B is dirty, which means it should remove the dirt, suck it. What is this? This is percept sequence. This is percept sequence. So this is the current percept. Current percept says that agent is in room A and room A is clean. The past percept says that is the previous percept. Whatever the previous percept it is this. The agent previously was in room A and room A was clean. Now in this case, in this problem, the decision only depends on the current percept. It doesn't bother about the percept sequence. So as we have already discussed, depending on the type of the problem, the action to be taken may depend either on the current percept or it may depend on the percept sequence. So this is a special case of problem where the decision always depends on the current percept. We can ignore the percept sequence. So this you can ignore. We are not bothered about this at all, because our action only should depend on this. A is clean, which means move right. Similarly, this is also the current percept is A is dirty. Previous percept is A is clean. So we need only current percept. So ignore the previous one. A is dirty means the agent should suck the dirt. Okay. So similarly, next is B is clean, and the previous percept is A is clean. So we don't bother about the previous percept. So B is clean means the agent should move towards the left. And this is current percept is B is dirty and A is clean. So we ignore the previous percept. For this problem we can ignore it. B is dirty, which means the agent should suck the dirt. And here this is A is clean, the current percept is A is clean, and the past percept is A is dirty. So we are not bothered about the past percept because this problem does not depend on that. So as the room A is clean, the robot should move towards the right. So on and so forth. This is how this agent will behave, or we can program this an agent to work on this small environment in this way, right? So what you should understand from here in the sense, See, this is a very small problem. But for this problem itself, you see how many rules are there. We are unable to list all the rules. We are unable to list all the rules. So this is a very small problem where there is an agent and there is only two rooms, and it should ensure that the room is clean. But still, if you want to represent it as a program, there are so many parameters you should consider. So when the problem space increases, when the size of the problem increases, the amount of data you need to handle will be extremely more. Okay, so that is one learning from this example we got. And now let us try to define the concept of rationality. What is meant by a rational agent? A rational agent is the one that does the right thing. But what is the right thing? How do you know what is the right thing? So to say something is right or not, we need something called as performance measure. So every time we should measure the performance of the agent. And then we should assess whether it is doing the right thing or not. So performance measure is, we can say it as an objective criteria which defines the successful behavior of an agent. So the performance measure is an objective criteria that defines the successful behavior of an agent. So if the agent is keep on satisfying the performance measure, then we can say that it is a rational agent. So in the vacuum cleaner problem, actually we should be very cautious in defining the performance measure. We should be very cautious in defining the performance measure, because this performance measure is going to make the agent rational. So it all depends on really our understanding of what is performance measure. If we define the performance measure wrongly, then the agent behavior will be altogether, it will be wrong. Okay, let us discuss this with an example. So in the vacuum cleaner agent problem, the performance measure of the vacuum cleaner should be what? This is the question. How could we say that the vacuum cleaner is a rational agent or not? So somehow we have to define the rationality and we have to measure the performance. So there are different ways to measure the performance for the vacuum cleaner problem. These are the different ways. One way is the amount of dirt cleaned. This is one way. Second way is amount of time taken. Third way is amount of electricity consumed. And the fourth is cleanliness of the floor. Okay. So these are some of the different ways of assessing the performance of the agent. So we are not going to use all the things, either any one you have to use, but which one you are going to use, that is very crucial. Okay. Let us assume that we are setting the performance measure based on amount of dirt cleaned. Okay, let us assume that we are setting the performance of the vacuum cleaner agent based on the amount of dirt cleaned up. So which means what? It means that if the vacuum cleaner removes more dirt, then we say that it's a rational agent. So that is what that is how we define rationality, or that is how we define performance measure. Based on the performance measure only, rationality is defined. Okay, right? So actually this is not a good measure. Actually this is not a good measure. Why it is not a good measure? Because we are concentrating on what is to be removed. See, here you are telling that the amount of dirt removed. So the agent will always try to amount of dirt removed. So the agent, so here what may happen in the sense, the agent, you are telling to the agent that if you remove more dirt, then I will give you more mark. That is, I will say that you are more rational. So at the end of the day, the agent may end up by doing something like this. The agent may clean the floor, then it may put some dirt, again it may clean the floor, again it may put some dirt, again it may clean the floor, like that it will do. Are you getting? Because how you are defining the performance measure? Because you are telling that it all depends on the amount of dirt cleaned. So it want to improve its performance measure. Because the agent is programmed that way. The agent is programmed to improve the performance measure. So it will pour more dirt and keep removing it, which is an unnecessary task. Okay. Similarly, if you measure the performance based on the amount of time taken, that is, if you say that if an agent is spending more time in cleaning the floor, then we say that it is a best agent or it's a rational agent. Then for removing the dirt, it may spend unnecessary time. Probably it may be able to remove the dirt in 1 second, but instead of 1 second, it may spend 5 seconds or 10 seconds or 1 minute there, because you are defining rationality as amount of time taken. So it wants to improve the time, increase the time. If you define the performance measure as amount of electricity consumed, then it may try to consume the electricity unnecessarily by moving here and there or by cleaning or doing all stuffs, right? So for this small problem, then if you take what is the correct way to define the performance measure, this is the correct way to define the performance measure. It should be cleanliness of the floor. So the agent should be concerned with what? The room should be clean. Both the room A and B should be clean. That's it. So that should be the objective. If you keep that as the objective, then the robot will not end up doing all these wrong things. Okay. So who is going to program? We are going to program. Then only the machine is going to take over. So as a human, we should be very cautious about the performance measure, which in turn decides the rationality. Okay. So the rationality actually depends on four things. It depends on the performance measure that defines the criteria of success, which we have discussed in the last slide. The agent's prior knowledge of the environment. So based on the prior knowledge, it will try to improve the performance. The actions that the agent can perform and the agent's subsequence to date. So the rationality, in fact, it depends on all these four things. It depends on performance measure, the agent's prior knowledge of the environment, the actions it can do, and it's the agent's subsequence to date. Okay. So with this information, for what is a rational agent, for each possible subsequence, a rational agent should select an action that is expected to maximize its performance measure. So simply saying, a rational agent is something which should select an action which maximizes its performance measure. Okay. So there are certain other things which we should know. Omniscience, learning and autonomy. So rationality is not omniscience. Omniscience means knowing everything. So we are not saying that the agent should know everything. It need not know everything. Given the information, it should do the best thing. That is what is called as rational. So rationality is distinct from omniscience. Omniscience is all knowing with infinite knowledge. So we are not trying to create an agent with infinite knowledge. With the limited knowledge, it should do the best thing. That is what is called as rationality. And the agent should be able to learn over a period of time. That is, the more the agent works, the more input it takes. Then it should be able to learn. Some form of learning should be built into the system. Right? The rational agent should not only gather information but also learn as much as possible from what it perceives. So we are not just gathering the information. So perceiving means what? Perceiving the environment and it's gathering the data. So from that data it should learn. And it should display some form of autonomy. So only if there is some autonomous feature, then only we can call it as an intelligent agent. Otherwise you cannot call it as an intelligent agent. Because, so these two things are key criteria for intelligence. Learning and autonomous, being autonomous. That is, it should be able to decide its own action irrespective of the program. The programmer may initially provide some basic knowledge, but later with data it should learn, it should be able to perform the right decision, or it should be able to make the rational decision. An agent is autonomous if its behavior is determined by its own experience, okay, with the ability to learn and adopt. So the rational agent should be autonomous. So the degree of autonomous, how much degree to which an agent is autonomy, that is more important. So, so with this info, let us so the agent so there is so we can specify the nature of the environment in which the agent interacts by this terminology PEAS. Here P stands for performance measure. That is, or you can say that any agent can be defined by this terminology PEAS. Where P stands for performance measure, E stands for the environment, A stands for actuators, and S stands for sensors. So let us try to understand the PEAS parameters for various agents. Let us take some examples to have more clarity. So let us consider this example: automated taxi driver. That it's autonomous vehicle. So in an autonomous vehicle, what should be the performance measure? The primary performance measure should be safety. After that, the speed at which the vehicle travels, whether it is following the legal issues or not, whether it is providing a comfortable trip to the user or not, whether it is maximizing the profit or not. So these are the performance measure. Environment. With what type of environment the agent interacts? It interacts with roads, other traffic, pedestrians, or customers. So it should be able to sense and differentiate what is the road, what's the traffic signal, who are pedestrians, who are customers, etc. What are the actuators in an autonomous vehicle? Steering wheel, accelerator, brake, all these are horns, all these are the actuators. Sensors, cameras, speedometer, GPS, engine sensors, keyboard, all these are the sensors which are connected with an autonomous vehicle agent. Let us consider a medical diagnosis system. Here the performance measure is defined by how healthy the patient becomes, minimizing the cost of the patient, and also following the protocols of the law of the what is the rule of the country. Environment. So it interacts with patient, hospital, the hospital staffs, etc. Actuators. Probably there will be some screen display. There may be some questions, or test or diagnosis, or all these things are the actuators. Sensors, keyboards, entry of symptoms, finding patients' answers, etc. Okay. So these are other examples. Part picking robot. Part picking robot is something like which picks. It's something like an automated. What do you call? It is just to identify whether a part is defective or not. Say from a machinery, some part is getting produced. Say let us assume there is an industry which creates cricket ball, Now some of this say whatever the cricket ball the industry creates, say assume that 5% of the balls becomes defected in a given day. Okay, 5% of the balls becomes defected in a given day. So there is a robot when a ball is getting created, the robot should check whether the ball is defective or not, and it should move all the defective balls to a separate bag. Okay, so that's the job of this robot. So this you can try as a homework. For this agent, what are the performance measure? What is the environment? What is the actuator? And what is the sensor? Similarly, there is another agent, interactive English tutor. Uh, for this, you can identify what is the performance measure, environment, actuators, and sensors. So basically, it is a tutor which teaches English. It is an interactive tutor, right? Then let us try to understand the different types of environment. So far we have concentrated on agent. Now let us discuss on the type of environment. The environment also can be of different types. So these are some of the classification. The first category is the environment can be either fully observable or it may be partially observable. In some cases, the environment is fully observable. For example, you take an agent which is to play the game of chess. Now The agent is limited to a very small world, and the world is limited to the chessboard. The world is limited to the chessboard. So here the agent can sense this board fully. It can fully observe the environment. That is, all the 64 columns it can sense, like which key is in which position, everything it can sense. So this you can take as an example for fully observable agent, fully observable environment. On the other hand, let us consider the example of what you call medical diagnosis. So medical diagnosis agent, it may ask or it may pose some question to the patient, and depending on the answer, it will try to diagnose the disease. So actually it is not fully observable because there are some degree of bias involved. The patient first of all may not tell everything correctly, either knowingly or unknowingly, right? Or sometimes the patient might have forgotten. So such environments cannot be called as fully observable. Or even consider autonomous driving. Autonomous driving, the whatever the camera that we fix for sensing the road or other things, it is limited. It's not that it can sense everything. No, it will sense a limited environment. Probably what is in front of the vehicle, to the sides, to a limited extent. So such environment are called as either fully observable or partially observable. So in case of autonomous vehicle, it is partially observable. In case of medical diagnosis also, it is partially observable. So this is one way of categorizing the environment. The other way is the environment can be deterministic or stochastic. Stochastic is otherwise also called as strategic. So what is deterministic? Deterministic means given the current state, the next state depends only on the agent's action. If that is the case, then such environment is called as deterministic environment. Is that clear? Given the current state of the environment is something. Now the next state, what will be the next state of the environment? That depends only on the action of this agent, which we are talking about. If that is the case, then that is called as deterministic environment. So chess is actually a deterministic environment. So if current state, as per the current state, if a particular coin is here, and if you want to move is here, then in the next state it will be here. That's it. After that, the opponent can move. That's a different story. We are talking about only the next state. The next state depends on the current state and the agent's action. If that is the case, that is called as deterministic environment. If the next state, if the next state depends on the current environment, the agent's action, and also the action of other agents which are happening simultaneously at the same time. If that is the case, then such environment is called a stochastic environment. So in a stochastic environment, what you can consider in the sense, there are multiple agents, there are not only one agent. So currently this is the state of the universe. I am going to take this action. The agent is going to take this action. But meanwhile, what are the actions that other agents are going to take, that I don't know. So the next state not only depends on the current and on the action of this agent, it also depends on the action of other agents that are involved in the environment. So that is called as stochastic or strategic environment. So for example, autonomous driving, actually it is a stochastic environment, because given a traffic situation or something, the agent may decide to raise up, move fast or slow down. But what about the opponent vehicle are going to do, that is not in our control. Is that clear? So, so the next state not only depends on the current state and the agent's action. The next state, it also depends on other agents' actions. Okay. So in that case, that is called a stochastic or strategic environment. Next is episodic versus sequential. Some environment will be episodic, whereas some will be sequential. Episodic in the sense, each action does not depends on the past action. The action that the agent is going to take now, that is no way connected with the past action. If that is the case, that is called as episodic environment. So my current action, if it also depends on the past action, then that is called a sequential environment. For example, we have discussed the vacuum cleaner agent thing. So vacuum cleaner is an episodic environment. It's an episodic environment because the next action the agent is going to do, it depends only on the current state. It does not depend on any of the previous state. Currently, if A is clean, suck it. If A is not, if A is dirty, move right. So it depends only on the current state. Based on the current state only the agent makes decision. Such environments are called as episodic environment. But if the environment depends on the previous set of actions what the agent has taken, then that is called as sequential environment. For example, chess is a sequential environment because next to what coin you are going to move, it also depends on the some of your previous moves. So that is actually a sequential environment. The robot picking up the faulty cricket balls, that is actually an example of episodic environment because each cricket ball is different. It's not that currently if the agent has picked up a ball as defect, then the next ball, there is no guarantee that the next ball should be defective or not defective. Right? Each task is independent of itself. In that case, we call the environment as episodic. Then the agent can be either static or dynamic. What is static? The agent is said to be static if the environment. It's not an agent, environment. The environment can be either static or dynamic. The environment is said to be static if the environment does not change when the agent is deliberating. That is, the agent is deliberating in the sense it should make some reasoning before taking the action. The agent perceives the environment and then it reasons. The reasoning is also called as, can also be called as deliberating, and then it acts. So when the agent is deliberating, if the environment does not changes, then such an environment is called as static environment. For example, you can say chess is a static environment because opponent has made a move. Now you can generally you can take your own time to make your move. And when you are thinking like what move you want to make, or when the agent is thinking like what move should be made, during that time the state of the environment is not going to change. So that is an example of static environment. Whereas in a dynamic environment, when the agent is deliberating also the environment can change. For example, the autonomous driving is an example of dynamic environment. So depending on the current traffic situation, the agent may decide something. Instead of taking the left route, I will take this particular route so that it will be traffic free. But meanwhile, other agent may but when the agent is making decision during that time also, the environment is going to change. Okay. And the agent can be either discrete or continuous. In a discrete, sorry, it's not agent, it is environment. I'm sorry. The environment can be either discrete or continuous. Discrete in the sense there are a limited number of actions. The actions or the percepts can be well defined and it is limited. In that case, we can call it as a discrete. That is, it won't change, the environment will not change continuously with respect to time. It changes discretely. Chess is an example for discrete environment. The opponent makes a move, this is the state. That state will remain as it is for a certain period of time until the agent is going to do the next move. Till that time the state is not going to change. That is, once the state has changed, if it remains in the particular state for a period of time, then we can call it as discrete. Otherwise it is continuous. For example, Autonomous driving is a continuous environment. The environment constantly it changes. There is no point of time where the environment will be discrete. Okay, so that is what is called as discrete and uh, continuous environment. Okay. In static and dynamic, there is also something called as semi-dynamic. Semi-dynamic means after a period of time, it may become dynamic. Say, for example, chess played with a clock. That is, the opponent should make or the agent should make the next move within a specified time. They cannot think forever. They can maximum take 2 minutes or 5 minutes. So in that case, we call it a semi-dynamic. Because if the agent is not taking action within that time, then the environment can change. That is, the opponent can make some other move, right? So that is static versus dynamic. Discrete versus continuous means the limited number of distinct, clearly defined percepts and actions. Uh, so this is with respect to this is not this is with respect to the type of actions the agent can take. Whether how many what are the different types of actions the agent can take? Is it a well defined set of discrete set of actions, or there is no definition on the number of actions it can take? So that is called as either discrete or continuous. And the agent can be either a single agent or multi agent. So in some environment there will be only single agent. In some environment there will be multiple agents involved. For example, there is a robot, vacuum cleaner problem, there is only single agent. Only that vacuum cleaner is the agent, no other agent. Whereas if you take autonomous vehicle, there are many agents are involved. It's become a multi-agent problem. Right? So these are some of the examples which says whether the particular problem is observable or deterministic or episodic or what. For example, crossword puzzle, if you see, it is fully observable because the entire field you can see. It is deterministic. The next move depends only on the current state and what action the agent is going to take. It's not episodic, it is sequential because your past move also determines the current move. The environment is static, it's not going to change when the agent is deliberating. It is discrete, that is the what actions you are going to do is well defined. So discrete is not concerned with it is concerned with the actions the agent can take. So is the actions are limited, so that is called as discrete. So it's a single agent. Chess multi-agent because there are two. There is opponent also involved. So let us see this medical diagnosis. It is partially observable. It is not fully observable. It is stochastic. It's not deterministic because the decision, the next state not only depends on the current state and your decision. There are many factors which will decide on the next state, in the sense the health of the patient. There are many factors which is going to determine the health of the patient. It's not only depends on the current health of the patient and what tablet the agent suggests, right? It is sequential. It is not episodic. It is dynamic. The environment can change when the software is thinking, when the software is deliberating. It is a continuous environment. It is not discrete. It is single agent. There is only one agent here. So like that, for a different agent, we can identify these things. Then let us try to understand what is meant by structure of an agent. So structure in the sense, basically we are talking about building an agent. So building an agent it includes the hardware and also the software. That is, it should have a hardware part for sensing, for reacting with the environment through actuators, all those things. And also there should be a software part which performs reasoning, which performs learning, etc. So the hardware part can be called as architecture and the software part can be called as program. So in this context, we can say that an agent is a collection of architecture and a program. So there are four basic types in order of increasing generality. So there are four basic types of agent we can define in order of increasing generality. That is, this agent is better than this agent, and this agent is better than this agent, and this agent is better than this agent. That is, their performance increase as you go in this direction. Now you can say this is a simple agent. This is a little complex. Complex in the sense more sophisticated. This is more sophisticated. This is a highly sophisticated agent. So what all these things? Let us try to understand. So first let us try to understand what is a simple reflex agent. In a simple reflex agent, the agent will sense the environment, and whatever it senses something. So based on whatever it senses, it will decide the next action. That's it, nothing else. Whatever the agent currently senses, based on that it will decide the next action. If that is the case, such an agent is called as a simple reflex agent. It's called as reflex. Reflex means, or you can call it as reactive. Whatever it senses, based on that it just reacts. That's it. So this can be defined with a function like this. Simple reflex agent percept, that is, it perceives the environment and it returns an action. So it contains some rules. Basically, this agent will have some program, and that program will contain some set of rules. These rules are some set of if-else conditions. Like, if this is what you sent, then do this. If this is what you sent, then do this. Like that, there will be some set of rules. So based on whatever it has sensed, interpret, input, percept. That is, percept is whatever it has sensed. Based on that, it will understand the current state. What is the current state? It will understand. Whatever it has sensed, based on that, it will understand the current state of the environment. Then already there are set of rules. Then it will try to match with the rule. This particular percept, it matches with which rule? So whichever the rule it matches, it will just select that rule and it will apply that rule. That's all. It is as simple as that. So depending on it perceives the environment, what it perceives, depending on that it performs the action. For taking the action, there will be some set of if-else rules, and based on that rules, it reacts. So such agent is called a simple reflex agent. And the next is model-based reflex agent. Model-based reflex agent is a simple improvement over simple reflex agent. Apart from whatever the task simple reflex agent does, it also keeps track of the current state of the world in an internal model, using an internal model. It always keeps track of the current state of the world using an internal model. So it senses the environment, whatever the environment it has sensed, it will keep track of it in the internal model. It will somehow store the representation of the current environment internally in the model. Internally in the agent, this representation is called as internal model. Then it perceives. Then again it perceives. So current state already it is available in the model, and also it perceives the environment. Now after perceiving the environment, it checks like, okay, this is the thing I have perceived. Now what action should I do? If I take this action, now how the world will change? If I take some other action, how the world will change? Because already the world is internally represented in the agent as an internal model. So it applies different options. Like, if I apply this rule, how the world will become. If I apply this rule, how the world will become. Like that, it will try to optimize. Then it will try to do the best thing, like whatever the best rule it's possible, it will apply. So that's the only difference between the simple reflex model and model-based reflex model. So it basically it stores the current state of the world. Then it senses, and then it checks like, if I apply a particular rule, how the world will look like now. And then given the set of rules
what is the best possible rule it will apply, and then it will act on the environment. So this is how the algorithm for the model based reflex agent. So it also perceives, it returns an action. So it includes what? It includes a state, the agent's current concept of the world, a model, a descriptive of how the next state depends on the current state and action. So using the model, it can check like if I do this action, what will happen to the next state? Like that, it can simulate internally how the world will evolve with respect to applying different action. And then there will be set of rules, basically if else rules, and set of actions the agent can perform. Okay. So how it updates the state? So it perceives the input, it perceives the environment, then it checks with the model like what action can be performed. By applying different action, it sees how the internal model changes, then it chooses the best action, and it fires the respective rule by calling the appropriate rule, and then the action will be reflected in the environment. So this is how model based reflex agent works. The next is model based and goal based agent. So this is next level of improvement over model based agent. So this is very similar to model based agent, but one more feature is added. The agent the agent is programmed to achieve the goal. The agent is programmed to achieve the set of goals. So it keeps track of the world state and the set of goals. The agent's primary goal is to achieve all these goals. So it need not be one goal. So that depends on the type of the problem. In some problem there may be only one goal. In some problem there may be more than one goal. So the agent, what it does in the sense, it's try to solve all the goals. So that's it. So other than that, it is similar to the model based agent. So here also it will represent the state of the model through a state of the environment through a model. It perceives the environment, it applies different rules and checks how the world evolves and which rule will satisfy which goals. Like that, it will check and it will fire the appropriate rules. The next is utility based agent. So what's the difference between goal and utility? So goal alone are not sufficient. We need utility. So goal. What goal says? Somehow achieve the task. That is what the goal says. But utility says that how best the goal can be achieved. So that's the difference between goal and utility. See, example, what I can say in the sense, goal you can say that passing in an exam. Passing in an exam, you can call it as a goal. That is somehow pass in the exam. That's it. Whereas utility means pass with the A grade. That is called as utility. So it is something more than a goal. Okay. So the goal which adds more happiness, or which provides more reward. So that is called as utility, right? Or pass in a exam so that you will get a job. That is utility, right? So it's not only goal. There is something else connected with that, right? So, or you can say that, so goal, you can say that reaching a particular place. I want to reach so and so place. But utility says that reaching the particular place in a very less time. I want to reach there within half an hour. So that is called as utility. So goal in the sense, reach there means you are not telling the time. So it may take 10 hours or 20 hours or 1 day or 2 days. Somehow you reach. That is goal, right? So that's how utility differs from goal. So in most of the real world scenarios, goals are not just enough to achieve high quality behavior. Yeah. So this term is very important. So utility, basically it defines the quality of the output. So goal does not talks about the quality. Goal says that somehow do that, that's it. Whereas utility talks about the quality of the goal. Some action sequences are better than other. Some action sequences are cheaper or quicker or more reliable. A utility function maps a state onto a real number which describes the associated degree of happiness of the agent. So, so as the utility increases, we will say that the agent's degree of happiness will increase. So, so degree of happiness is some parameter which is attached with the agent, and this parameter will increase when the utility increases. Okay. So utility based agents are very similar to goal based agent, but here one more thing is added. It should always try to increase the utility, improve the utility. How happy I will be in such a state. That is, if I apply this rule, the world will change like that. So how much happy will I be? Will I be more happy than from the current state? Then go to this change. So here happiness is measured by some number, right? So the more the utility for this happiness, you will associate more high number, or you can say it's a weight. The number associated with the happiness, we can call it as weight. So we want to increase the degree of happiness or the utility. Expected utility is computed by averaging over all possible outcome states weighted by the probability of the outcome. So this is how we can calculate the expected utility. Is computed by averaging all possible outcome states. Okay, and I mean in a given time, in a given situation, what are the possible actions an agent can take? Sum up all those things, right? All possible outcome states weighted by the probability of the outcome. That is, uh, that is for each of that you connect a probability. From a current state, for example, there are three actions you can take. A1 you can take, A2 you can take, A3 you can take. Then what is the probability of choosing this action A1? This will be associated with the weight W1. What's the probability of choosing action A2? This will be associated with the weight W2, multiply. W1 into A1, W2 into A3. This will be associated with the weight W3, W3 into A3. Now add all these things and divide by 3. Because there are only three possible actions. So that is called as expected utility. So expected utility is computed by averaging over all possible outcome states weighted by the probability of the outcome. This W1 is nothing but the probability of choosing A1. W2 is probability of choosing A2. W3 is probability of choosing A3. Okay. So there is also another important thing. The agent should be able to learn. Fine, up to utility it is fine, but alone up to this stage alone it's not sufficient. The agent should be able to learn. So so we want to create machines which can learn by itself. You cannot program. I mean, all the intelligent aspects cannot be programmed to a machine. The, I mean that all the intelligent actions you cannot program to a machine because intelligence is very broad. So we should make the machine to learn by itself. So that is what learning talks about. Programming intelligent machine by hand is extremely time consuming because intelligence is not limited. It's a very vast field. So you cannot give all intelligence. Rather you can make a computer to learn by itself. You can write a program where learning happens automatically. So this is not a good method, or this is not an advisable method. Programming intelligent machines by hand is extremely time consuming. So what's the better method? Program a learning algorithm and then teach machines what they should learn. You make a program and make that program to learn with data. So some of the examples for this type of algorithms are ANN, artificial neural networks, support vector machines. Basically all these are machine learning or deep learning techniques which learns by itself. With more data it learns better, right? So let us make there are, and reinforcement learning is also an example of this category. Okay. So learning is nowadays the big issue in AI. So how can we make the device learn? And we are already achieving a good degree of success in this area. Today AI is boom because of learning, because of because of machine learning and deep learning. So from our original list, we add one more agent, that is learning agent. So there are 5 or 6 types of agent we have discussed. Simple reflex agent, model based reflex agent, model based and goal based agent, model based and utility based agent, and then learning. So utility alone is not sufficient. The agent should be able to learn. So this is very similar to that of an utility agent, but it also includes the learning parameter. So these are the components of an agent that can learn by itself. There should be a learning element, there should be a performance element, there should be a critic, and there should be a problem generator. All these are here in this agent. There is a learning element, here is a performance element, here is a critic, and here is a problem generator. So the learning element will always check the performance of the agent. The learning element will always check the performance of the agent through this performance element. This performance element will give the performance. So the learning element will every time it will check what is the performance of the agent, right? So is the performance is a good degree or not? Like that it will always check. So performance in the sense whether it is acting rationally or not, whether it is acting rationally or not. Based on performance only rationality is defined, as we have already discussed. And what is a critic? A critic is one which either criticizes the agent or appreciates the agent based on the agent's action. Whenever an agent performs an action, the critic will either criticize the agent or it will appreciate the agent. So how the critic will criticize or appreciate based on the performance standard. So there is this critic knows what is the performance standard. So if the agent's performance is not matching to the standard, then the critic will criticize. If the agent performance is matching to the standard, then the critic will appreciate the agent. Is it clear? So based on the critic's input, this problem generator works. For example, if the critic is criticizing the agent, if the critic is saying that the action that you have made is not so good, you can improve upon, like that if the critic says for whatever the action recently the agent has made, then the problem generator, what it will do in the sense, it will look over the other possibilities that it can do in the given situation. So problem generator means here it is not actually problem generator, it's a solution generator. So for the given situation, what are the other possible actions the agent can do, and will improve the performance measure or not? Like that it will check. And here some learning happens, and when next time the same situation occurs, now the agent will try to react in a different way because previously the critic has criticized. Is that clear? Suppose if the critic has appreciated for some action, then the problem generator will record that this is the best action in this situation. So when next time that particular situation arises, it will react in the same way. So learning happens because of that. Because of all these things, learning happens. Okay. So learning element is responsible for making improvements. It uses feedback from the critic on how the agent is doing and determines how performance should be modified. So these are the activities of learning element. It does all these things. It receives feedback from the critic on how the agent is doing and determines how the performance element should be modified. And performance element is responsible for selecting the external action. Critic, it tells the learning element how well the agent is doing with respect to performance standard. Problem generator is responsible for suggesting actions that lead to new way of acting or new way of reacting to the environment. Fine. So that's it about the various agent and the environment. So we have discussed what is an agent, what is a rational agent, and what are the characteristics of an agent, and we have discussed an example agent, the uh, vacuum cleaner agent. Okay, and what are the task environment, like we have discussed, it is PAS, right? So it involves perception, environment, and what action it takes, etc. All these things, and we have discussed the different types of environment. The environment can be fully observable, partially observable, whether it is deterministic or stochastic, dynamic or static, etc. And then we have also discussed different types of agents, like what model, simple reflex agent, model based agent, model based and goal based, model based and utility based, and learning, right? So so learning and being autonomous, these are the important characteristics of an intelligent agent. Fine, let us stop here. Thank you.